Hi kids, how are you doing? I hope that you're doing fine. I have been struggling so much to record this lesson, like it has been super hard because it involves so many different things, now the technology, and I don't know, I am not a very uh, technological literate person. So sorry that this session is coming a little bit late. So, okay, we're gonna do this. Uh, Sorry that this is a little bit already marked with my already dirty with pencil because I have tried to do this many times and I am not very good at video editing. Um, when I was young, there was no thing as TikTok. No, maybe you are more literate at doing videos. So we have a situation. Margie, she has 3 cats, and each cat, 2 of her 3 cats are here and here, and they want to stand at the same distance from each other. That means that this distance, let's call this distance R. This distance, let's call this distance R. I want that at this same distance to find another point that it's at the same distance from J and the same distance from S. So what are we gonna be doing? We're gonna open the compass at a distance of R, and then we're gonna draw the circle around S of radius R. All of these points are at distance R from S. For example, J is at a distance R from S. Now, if I do the same, if I draw a circle that passes through, if I draw a circle that passes through J with a center in J, then this is the circle of all the points that are at distance R from J. So for example, here in the intersection, this point is at a distance R from J, and it's also at a distance R from S, because these 2 points belong to a circle, because this point belongs into 2 circles. So sorry. The whole thing that we're going to be doing in this class is doing constructions. What does that mean? So when Egyptians created the pyramids, when Mayans created the pyramids, in all of the antique constructions of the world, using a ruler was not very reliable. And think about that, no? Because now I know that a centimeter is this. But like, how is universally accepted what a centimeter is, no? Also, like measuring, it's sometimes inaccurate. So how would we do constructions like measuring things or copying things, or the things that we do for architecture right now, without relying into measuring distances? Well, the secret was using a compass, using a ruler, and maybe using a set square. It is very interesting that, for example, the Masons, like this cult that rules the world in a very secret society fashion. I'm joking; they don't rule the world. But it's very interesting that the symbol for the Masons is a compass and a straight edge, because the Masons were not the architects, but the builders of these very important monuments and places around the world. So when we do this, when we do this constructions, I want you to feel like those very antique mathematicians in Greek islands. I'm sorry that you can see this and this. It is because I have tried to do this video many times. So, the first construction that we need to learn, the first skill that we need to learn, is how to construct a triangle. In the 4 skills that I'm going to give you, I'm going to ask you to write the steps in your own words. So I'm just gonna say it, and you will do it in your own words. Write them down, because you want a reference. You want to go somewhere to remember. So, how do you do this? I am giving you 3 sides, and it's so cool because I am not giving you the measurements, but I am actually giving you the lengths. So we are totally independent from measuring with centimeters or anything. So you do the following. First, you draw a point, P. Then you measure the length of the first side with your compass. And standing in P, you draw an arc. So first step, point. Then measure a side, arc. Over the arc, I'm gonna select a point. Any point. I decided here because I want to draw it over the one that I just did like 20 minutes ago. But you can decide wherever you want it. No, if you want to put it here, if you want to put it here, or if you want to put it, complete the circle and put it here, you decide. So, but I'm gonna put it here. Then my second step, after the second point, I'm gonna measure the distance of side 2. Now that I measure the distance of side 2, I draw a circle. I draw a circle. Standing in P at a distance of side 2. Then I measure side 3, and standing in Q, I draw, oh my god, I draw the other arc. Sorry, it moved a little. So, as you can see, you have created with your compass this little cross. This is the circle of points that are at the distance side 2 from P. And this is the circle of points that are at the distance side 3 from Q. So this intersection is exactly at a distance side 2 from P and at a distance side 3 from Q. Then you connect the points. I'm gonna draw the isosceles triangle, and I'm gonna draw it in another piece of paper. If I had a piece of paper. If I only had a piece of paper. Excellent. So, again, we're gonna repeat the same procedure. So I am giving you the two sides, because an isosceles triangle has a base and 2 congruent sides. So I'm gonna open up to the distance of the base. Remember, a point. I'm gonna put a point here. Now at the distance of the base, I draw an arc. Now over this arc, I mark another point. I'm gonna put it here. Then I'm gonna open to the length of my second side. Standing in one of my points, I draw an arc. I open to the length of my side, and standing from the other point, I draw an arc. And where these 2 arcs meet, in this cross, that is the location of my third vertex. And then you connect the lines. And I find this chilling, relaxing, and pretty. It is such a perfect isosceles triangle. Okay. Now, our second skill is copying an angle. So I'm gonna give you the steps. I'm gonna tell you the steps, and you will write them down in your own words. I open my compass, and okay, I put a point. Sorry, I put a point. First step, put a point, because you're copying. Put a point. Draw a ray. At any openness, you can decide any openness, but just keep it. I'm gonna do it like to this openness. Draw an arc in your original angle. Then, with your compass, measure how big the angle is, and you can say, oh, it is the same. Well, not always is the same. And with that openness, the openness that you measured, I committed a mistake. Sorry. I'm not gonna repeat the video. Sorry. It's like the third time that I repeat the video. I'm not gonna repeat it. Like the fourth time, actually. So, second skill. You draw a point. Maybe I will edit it, or maybe not, just for laughing. Okay, then point ray. You draw an arc, any arc. You decide the length. Draw an arc with the same openness. You draw an arc. Okay, so point ray, any arc. And in the copied angle, draw an arc. Third step, measure the openness of the angle. And standing from the intersection, you draw an arc. So, where the two arcs meet in the intersection, that is a copy of your angle. And it is super cool. I am sorry that I committed a little mistake. So, point, ray, draw an arc, any openness, draw an arc, exactly the same openness, measure with the compass, draw an arc, and in the intersection, there's where you have your ray. Okay, let us do it with the second one. So again, first, point and ray. Point, ray. At any openness, I draw an arc. I draw the exact same arc. Then I measure the openness of this arc. Excellent. And in the intersection, I draw my second arc. Where these two arcs meet is where I have to draw my ray. And it's super pretty. Super pretty. Okay, my third skill, bisecting an angle. So, bisecting, remember that means to cut into two congruent parts. So I'm gonna do this. I'm gonna open my arc, my compass, and draw two arcs at any distance. I don't care at which distance, at any distance. And then I'm gonna do two arcs, this and this, one in each ray. Then standing in the intersection with the same openness, I draw an arc standing on each intersection. So I did not change the openness of my compass in the whole procedure. I draw an arc here, I draw an arc here, and then standing over each ray, I draw two intersecting arcs.